Okay, so it's almost 8:10. Let's start the class. So let's discuss the subjective questions first. Objectives were easy. I will provide you with the answer key. I think that will be enough. So this is mock test 2. The first question was prove that sum over j runs from 2 through n and cj times 2 power n minus j times jc box of j by 2. This thing equals to n plus 1 cm. So yeah, so how to do this one? Anyone tried? I hope all of you attempted the question paper, so you must
Uh,
have. Yeah.
in this, we can prove that this LHS thing is just the power of x to the power n in the expansion of 1 plus x to the power 2 1 plus 1.
Can you repeat x to the power n?
I mean, this is the power, coefficient of x to the power n in the expansion of 1 plus x to the power 2 1 plus.
You mean this? Like this
Uh,
is the
yeah, 2n
this
plus
is the
1.
this is the right hand side, right?
Yeah, we can prove this.
Okay. Okay, so let's do it step by step. How to show this is the coefficient of this thing. So we will try to rewrite this in this way, like 1 plus
Sorry, telling.
x. Yeah.
Okay, I thought I need to tell. Okay, you can.
Okay. So we can write it as 1 plus x times 1 plus x power 2n, right? And then this factor, like we can expand that 2 here. So we can write 1 plus x squared whole power n. So this is our RHS. Then we can factor out, sorry, we can factor out the n here, x power n here. Write it as uh, okay. So x plus 2. I mean, sorry. So this is that. So now, like coefficient of x power n, and here we have factored out x power n. So this has to be a constant term for this to be a coefficient of x power n, right? So this is the coefficient. Now let's try to morph it into this form. So, okay, so for that, observe that this thing can be written as x power minus
Sir,
n
excuse
plus
me. This is which mock test answers?
the last one that I posted on Google Classroom last week, that 4 hours
Okay,
one.
sir.
Yeah. So, plus 2. Now, Now we can use binomial theorems to expand this. Uh, actually, so let's rename a few variables. Which one should I rename? This one. So let that be capital N. Now small n runs from small n. I runs from 0 to n. X power minus n plus x power I times 2 power n minus I times nci. Right, so we have got that nci term. We have also got that n minus I term. Now just this term is left. Okay,
So
thing
what
is,
is the capital N for?
like if you may confuse with this n and this n, right? Like, so that's why I am writing it as capital N here and small n there.
No,
Like actually,
what for is that capital N? Actually, I didn't understand that, sir.
okay, capital N is equal to n, right? But here it's a constant. So capital N here is not a constant here. Like this thing is evaluated at n, capital N equals to n to get the coefficient of x power capital N or x power n. But here this n is a constant and this is a variable. So that's why I was, or you can just continue with that small n thing. Increase complexes. Right, so now let's find out what is the coefficient of x in the expansion of 1 x power 1 minus n. Okay, we can take this thing inside, right? So it is sum over I runs from 0 through n. So what is the coefficient of x here? No, what is the constant term here? So coefficient of x power 0 here. Like we need to find the constant term in this whole equation. So this is constant term. So the constant term can be obtained in two ways: when x power minus n plus x power I. This gives a direct constant term, and when x power plus x power I times x, the constant term is in this whole thing. That is when this is some x, like when this is some x power 1 into some constant x power 1. So that is like ICJ x power minus n power j and x power I minus j. Right. Guess I'm messing up something. Okay. Yeah, so when I pulled out x from here, this shouldn't have been minus n, this should have been minus 1. Sorry, that's why I was wondering why n was coming up here. right? So it's this thing that's equals to x power I minus 2j. That thing here. When is this equal to x power 0? That is when I minus 2j is 0. That is when j equals to I by 2, right? So this is an integer. Integer if and only if I is even. So when I is even, when this I is even, then we will get a coefficient. What is that coefficient? ICJ as the constant term from this side. Now let's this is I by 2. Now let's see what we get from here. So here we have ICJ x power minus 1 power I, sorry, j, and x power I minus the same thing. But here we need to have um, minus j plus I minus j equals to x power 1. Oh, sorry, x power minus 1. Right, since sorry. So to nullify this x, the coefficient of x bar 1 will be the constant term, the contribution of constant term from this whole term, right? So that's why I'm equating it with x bar minus 1. So we have I minus 2j equals to minus 1. That gives 2j minus 1. Sorry. That gives I plus 1 by 2 equals j. Right. Should it come I plus 1? Is x power minus 1 power I minus j times x power 1 power j. Right. That's why I was getting it in minus. Okay, so that's what we are getting. So this implies this thing contributes I see I plus 1 by 2 when I is odd. That implies on an average x plus 1 times 1 plus x power minus x plus x, this thing whole power I has a coefficient as I see box of I plus 1 by 2 as the coefficient of x bar 0. So that, I guess, proves our problem. So coefficient of x in this thing 1 plus x times 1 plus x power 2n is coefficient of x in coefficient of x constant term in. And that constant term, as we just calculated, is I 0 psi I c box.
Sir, I have a different way to do
Oh,
this.
okay, so method 2.
Can I tell?
Yeah, please
I
continue.
I mean, the idea is same that we have to prove that it is coefficient of x to the power n in the expansion of like 1 plus x to the power 2 and plus 1. But we can prove this in more easier way, I think. We can we can basically write 1 plus x to the power 2n plus 1. Can you please write? Yeah. Is equal to 1 plus x plus x multiplied by like whole multiplied by 1 plus x and 1 times 1 plus x whole square to the power n. And then this 1 plus whole is x whole square you can expand like 1 plus x, it will be 1 plus x times 1 plus x square plus 2x 1 plus x, no, we can just expand 1 plus x square plus
Okay,
2x
okay. 1 plus x squared.
plus
Uh,
2x.
okay, you are expanding inside it. Yeah, that's what
Yeah,
I did.
yeah. And then we can see that then again we can expand it more. It will be 1 plus x square plus 2x to the power n plus x times 1 plus x square plus 2x to the power n.
Yeah, then we will get some expansion. So,
And then we can expand this 1 plus x square plus 2x to the power n like binomially by our one, like taking 2x as one thing and then second as 1 plus x whole square. And then we can expand it, then we will get that when j is even, this is the power of like when j is even then this works, and when j is odd then that works. So overall it is the coefficient of n in this expression.
yeah, basically that's what I did. Just,
But like it's look
yeah, I messed up a bit with that -1, so it, and I was not doing it in a single, like from left hand side to right hand side. I started with the right hand side and tried to morph it into, so
yeah, we can write
yeah,
like this
it's
also,
so
right? I mean it is
yeah,
little
it's
bit cleaner.
okay. That's okay. So, so it's the same method only. So we just try to find the coefficients of x and the x power n in this term, 1 plus x squared plus 2x whole power n. So let's move on to the next one. So that's a geometry problem. So just let me draw the figure. So the circle. The triangle ABC and then the incircle. next, the center. AI intersects the circumcircle of ABC at a point D. Circumcircle of CDI intersects BI at points I and K. CDI. Circumcircle. Okay, BI intersects CDI intersects BI at points I and K. K must be somewhere here. We have to show BK equals to CK. So it seems a pretty good drawing. This already seems isosceles. So we have to prove that. So how to proceed now? Anyone?
We can show that angle KCD is equal to B by 2 plus A by 2. KCD.
Okay, KCD. You mean
Yeah.
this is a big one.
Yeah, this
B
is
by
equal to B,
2 plus C by 2.
and then we can subtract it. Because
So,
BCD,
yeah, continue.
because BCD will be A by 2, so we can just subtract that. I mean, we can prove it by some cyclic argument, because KCD is cyclic, and this KIC is equal to angle uh, angle A by 2 plus C by 2, and angle B by 2 plus C by 2. So of course that KCD will be A by 2 plus B by 2, because angle KID plus KCD is 180. So, and then we will exclude BCD because it is A. So overall it will be B by 2, hence BK is equal to C.
Okay. So let's start with this angle. So angle A, this is angle A, this is angle A. So angle PIC is twice angle A, and angle BI, call it some E. So BIE is equals to angle PIC, which gives us angle PIE or BID is half of twice of A, so it's A. Right. And angle BID is also equals to angle just a minute. Is that true? I don't think so.
What?
But this is not the circumcenter, right? So why should it be just a minute? PCD. This is so KCDI is a cyclic quadrilateral. So angle C, I mean angles, not C, angle KCD equals pi minus angle KID t, and angle KID is equal to angle AIB, and angle AIB is equal to um, so 180 minus AIB is this angle plus this angle. Kind of getting lost. Can you just
Basic,
yeah, help me out a bit?
basically, basically,
Yeah.
like angle DIC will be A by 2 plus C by 2 by exterior angle property. Yeah, DIC, not BIC. Yeah, by exterior angle property, right?
DIC is A by 2 plus C
C
by
by 2,
2.
right? Because AD is a straight line. Exterior angle property, like angle IAC is equal to A by 2 and ICA is equal to C by 2. So both will be summed to get DIC.
Okay. DIC. So you mean this angle?
Yeah, this is equal to basically IA plus C, angle IAC, like DIC is
IAC. This.
plus angle ICA, right? I
Yeah,
mean,
yeah, yeah.
so it is basically A by 2 plus C by 2.
Okay, so yeah, so this is true.
And hence also by same logic CIK is equal to B by 2 plus C by 2.
CIK is, so this
B by
thing
2
is, yeah, so this is
because
nonce.
it is just sum of angle IBC and ICB by exterior angle property by same.
Mm-hmm.
and
This is I.
and yeah,
CIK is this angle. This angle should be this thing plus this thing.
mm,
So it's C by 2 plus B by 2.
yeah, and so DIK is equal to A by 2 plus B by 2 plus C plus C, and hence angle KCD is equal to A plus B by 2, right? Because cyclic quadrilateral. ACD,
Sorry, yeah.
not ACD, I think, or I'm missing. No, sorry, KCD, sorry. Yeah,
KCD. So KCD is pi 180 minus DIC.
DIK.
Yeah, DIK. Sorry, that was also, I mean, yeah, so it's 90 minus C by 2, 90 minus C plus 90 minus A plus B by 2.
Which is basically A plus B by 2, right? Because angle A plus B plus C is equal to 152.
Yeah, yeah, so it's A plus B by 2.
And as ABCD is cyclic, so angle uh, BCD is equal to A by 2. So KCB must be B by 2.
We started with this one and showed this one. Six C by 2, and then we have a angle A plus angle B. Now just a minute. What is 90 minus angle C?
Sir, what?
What is 90 minus, what is the first term?
I mean, I'm just doing that. We know that A plus B plus C is 180, right?
Yeah.
So just instead of writing 180, write A plus B plus C.
So we have A plus B plus C minus A
C.
plus B by
A plus B
2
by 2
minus C.
So it is A
B
plus.
is cancelled, so A plus B by 2. Okay, so KCD is A plus B by 2.
Yeah.
KCD.
And BCD and BAD is same, which is essentially A by 2. So KCB must be B by 2.
This is B by 2 and this is also B by 2.
Yeah.
So
Done.
that shows BKC is isosceles. So that means, so should I, everyone else get the argument, right? Should I repeat it once? I don't know if I will be able to, but still, this drawing is getting messier. So. Is it getting deleted? Don't know. First, we showed that angle DIK. So, what is angle DIK? This is KIC plus angle DIC. KIC is like, so KIC is the angle B plus angle C by 2's, these two, this angle and this angle. Yeah, this angle is. Similarly, DIC is the top one, A by 2, and this one, C by 2. Okay, so that gives us, so it's A plus B by 2 plus C. Then we have from cyclic quadrilateral KITC, angle TCK is 180, that is angle A plus angle B plus angle C minus angle A plus angle B by 2 minus angle C. That is angle A plus angle B by 2. And also, since the chord BD subtends both angle BAD and BCD, so angle BCD equals angle BAD equals A by 2. Since uh, in center is the intersection point of the angle bisectors. So this, yeah, it's angle A by 2. So we get DCK minus uh, DC DCB equals to angle B by 2. That is KBC. Right, and this is KCB. So that implies triangle BKC is isosceles. Coolness. So so now the third one. Prove that any integer. So any integer can be written as the difference of two numbers such that both of them have the same number of prime factors. So we have an integer n. We have to express it as the product of two numbers, p and q. Two numbers. Can they be different or nothing is stated? So number of prime factors. So let what can we say? Psi. So let psi n be the number of prime factors of n. So psi n number of prime factors. Prove that there exists PQ in Z such that Pn equals to P times Q and psi P equals to psi Q. So how to do this one? I guess for n some perfect square. So like if n is some perfect squared, then it's obvious it's n times n, or even for even numbers. So if
For even number, we can write n is equal to 2n minus n.
yeah, so n equals to n minus n. So this one has all the factors that n has, including 2. And this also doesn't have any new factors since 2 is already there in n.
And
Now
when
what
n
about
is
odd now? Yeah.
and when n is odd, we can just write it as pn minus p minus 1n, where p is the smallest prime divisor of smallest prime which doesn't divide n. Smallest prime which doesn't divide n.
My p is the smallest prime factor, no, not factor, number, which
which
or
doesn't
such
divide.
that, yeah.
Yeah.
So then how many factors does this have? This has psi n plus one number of factors. What about this one?
This
So
also has psi enough plus one.
yeah, so what is this? This plus one, this is a two. The since yeah, actually this is the smallest odd prime number such that p doesn't divide
Yeah,
n.
yeah.
Then
Forgot.
this is an even number, so we are getting 2 as the extra factor while the first term is p as an extra factor. Actually, I didn't I just I don't know multiplying between it. So just define n equals to 2n minus n when n is even, and equals to pn minus n when n is odd, such that p is also the smallest. Okay, so smallest such p. Uh, is that clear? So everyone, like, hope this is clear. Quite easy. Now we have the fourth one. So this one says n and k are two natural numbers, and a1 up through am and b1 up through bk are positive integers. So bi's and ai's are all integers. We are also given this equation that sum over ai power 1 by n is equals to sum over bi power 1 by n. We have to show first we have to show m is equals to k. This holds true for all n in naturals. Second, you have to show their product over ai is equals to product over bi. This is this is k. So this one is quite easy. You just take limits on both sides since it's true for all n. So taking limit n tends to infinity, we get now all these ai's and bi's are constants. So a constant power 1 by n where n tends to infinity will surely be 0, right? And finitely many terms going to 0 will add up to another 0. So we get LHS equals to RHS. Just a minute. am I doing later? So this term is 1 actually. So this adds up to n. So LHS adds up to n. The RHS adds up to k. And so this implies n equals to k. So we are done with claim 1. Now for 2. So we can take log on both sides. So this one holds if and only if log of this one holds. If and only if sum over log of this one holds. If and only if limit of sum of uh, okay, we can multiply both sides by this. Let me think about. So we have to show both of them are equal. Now the sum both runs from 1 through m. Since we have already shown m equals to k, how to show these two are the same? Sorry, this is product over ai. So no 1 by n. We have to somehow introduce n here. Somehow transfer it into this equation.
Basically, we can subtract m from both the side in the original equation and then divide by n, m, and then take the limit m tends to infinity. I mean, then it will be lna, right? The limit, uh, yeah, by m. Yeah,
I mean, then it's basically 1.
by m. I mean, we can divide also by m, right? And then we can take the limit,
No,
basically.
we can't take m to infinity, right? We can only take n to infinity.
Wait, can you show the question once? Okay, we have this.
We have to show it for all n. We have that equation. These are all n, and we only showed m
No,
equals
no.
to k.
Yeah, yeah, we can divide by n. We can divide by
We
n,
can
not m.
divide by n.
And then we can take n tends to infinity, which is lna, right? Every limit will be lnai, and here lnbi.
Yeah, yeah. So now we can take. So if we want to do it in this bottoms up manner, what should we write next? This is limit n tends to infinity. Sum over 1 through m. ln ai is basically Or from the LHS we can just write it like, I mean not LHS, from our given equation. So we have this given. So we have this taking limit, then we can take the limits inside to get the lnai's and lnbi's. Why is that? Since a power x minus 1 by x, this goes to ln x. Just does it go to ln x? Goes to ln x. It's the expansion of a power x. A power x is an expansion of 1 plus ln a by 1 factorial plus ln a squared by 2 factorial. So we are subtracting 1 from that. So now we are getting this. We should divide that by ln a. No, we can divide it by x, or oh, yeah, I'm missing the x. So ln a power x has an expansion of 1 plus x ln a by 1 factorial plus x square ln a by 2 factorial plus dot dot. Right. So by x, and we send extend to infinity. So e power x minus 1 by x get ln a. So here we say n2. I mean, this is 1 by n. Oh, yes. That's why we needed to multiply with n. Okay. So we send n to infinity. That gives us ln a. Right. So here we have some more items from 1 through n. Limit n tends to infinity. N times ai power 1 by n minus 1. Okay. Then we have, we take the limit outside, and we also take the n outside. ai power 1 by n minus 1, and similarly for this side. Then we can cancel out the ones from both sides and also cancel out the n from both sides. So we get limit n tends to infinity. This is obviously true since uh, each summation I runs from 1 through n ai power 1 by n is 2 for all n, right? That's what was given in the in this question statement. So that was it. Question number 4. Now question number 5. So here we have an inequality with three non-negative integers. I should say. And these are real numbers. Okay. So r plus with 0. We have to show a times a minus b times a minus 2b. So cyclic sum greater than or equals to 0. How to solve this one? Um, any, any like short method or something like I know a very uh, not so elegant looking solution, but if anyone stumbled upon something brilliant or something easier to understand, then please. So without loss of generality, we can assume some order between these three integers. Now suppose this gap is x and this gap is y. So we have b equals to x plus a, c equals to x plus y plus a. Okay. Or we can just make this y. Therefore, our inequality is now no longer cyclic. So it's a times a minus b times a minus 2b plus b times b minus c times b minus 2c plus c times c minus a times c minus 2a. And only if so it's a minus b is minus x, minus 2b is minus a minus 2x, b is a plus x times b minus c is so it's x minus y, x minus a minus 2y plus a plus y times c minus a is y, c minus 2a is y minus a. So if and only if we simplify, so we have let's say squared x minus 2x squared a plus ax minus ay x squared minus xy. Y squared y minus a a squared x, 2x squared a. So it's ax squared, axy, x cubed, x squared y, a squared x, a squared y, ax squared. This is plus ax squared, axy. Last one is 2y. So 2y, 2axy, 2ay squared, 2x squared y, 2xy squared. Ay squared, y cubed, a squared y squared a. So this gets cancelled, this gets cancelled. Minus a squared y plus a squared y minus ax squared plus ax squared. Nothing more. Yeah, minus a squared x plus a squared x. Left with x cubed, y cubed, x cubed, x squared y. So let's see what we are left with. So we have a times minus 2x squared a. We are left with that. Minus xy minus xy y squared. Just a bit, I guess I'm missing now somewhere. Shouldn't be that bad. Here I missed a 2 x minus 2. Also any. Okay, so I seem to have missed a lot of things. So this is b minus c. Wait a minute, what was the? Oh, that was this term, right? But then that was okay. How did I erase that? X minus a minus 2y. C was a plus y times c minus a is y, and c minus 2a is a plus y minus 2a, so a minus y minus a. Next we multiply, so we get plus a squared and plus 2x squared, right? Here we get ax a minus ay plus x squared minus xy. Okay. Next we have ay plus y squared and y minus 1. Square x minus 2x squared a plus here we have ax squared minus axy x cube, then minus x squared y. This should have been plus. No, this is okay. This is minus. Then minus a, we have minus x squared plus a squared y. This is minus ax squared. Then plus, yeah, this is plus axy. The last one we have minus 2y. So minus 2xay plus 2ay squared minus 2x squared y, and the last one is plus 2xy squared. So we have ay squared y cube and minus a squared y and minus is y squared a. So here we got 2axy cancelled. So without them, we have of course an x squared and a y squared. Then we have 2xy and nothing else. Plus we have x cube and y cube minus 2x squared y plus 2xy squared. So there is another minus x squared y. So we have 3x squared y. We should actually have another xy squared. Xy squared, yeah. Xy squared. Even if we don't have, let's settle for without one. So this is already a perfect squared. This one we have what to say about this term. So x squared y, 3x squared y is obviously smaller than x cube plus y cube. Okay, like not 3 but 2x squared Here we have x cube plus, not plus, if we have x squared y, then plus, we take it 3y squared, and minus y cube, and then again add y cube. What did we lose more? Yeah, we have a minus xy squared. So this thing is x minus y whole cube. No guarantee it will be a positive, so that means that factor is this one. Taking common x squared, we have x minus 3y. Here we have y plus 2x. Just a minute. So anyone, any idea why this should be positive, like always? I don't see how. Take common xy, this is minus 3x plus 2y. Like x and y all are positive, right? So 3x squared y. This is less than x power x squared power or Okay. So with our assumption, we also have assumed one more thing, that y is greater than x. So y cube is greater than x cube. Can this help us? If we replace everything with y here, stop doing this. So everything with y. So this is, so this thing, this whole thing is greater than or equal to, this is x minus y squared plus y cube plus y cube minus 3y cube plus y cube. Right, so then it's surely positive. Yeah. That's so great. I don't know what happened to this talk this time. Yeah, so that's proves this inequality, which is true. Okay. So three more problems left to be quick. Sixth one. We have a real number sequence AI. We also have a recursive relation am plus n plus am minus n equals half times a to m plus a to n. This is for all positive mn. The m is greater than or equals to n. A1 is known to be 1. We have to find the closed form for an. So how to proceed? Just we have to substitute different values for mn and n. The first obvious choice is obviously m equals to n. So putting that, we get 2m a0 a2m a2m. So we get a naught equals to 0. Next we can put one of m and n 0. So let's go for n equals to 0. So we have am plus a0, sorry, an equals half times a2m plus a0. That gives a0 is 0, so a2m. Right, so no, sorry, we have a half here. So a2m is 4 times am. That is A2m is 4 times 4 squared times am by 2 and so on. So, so obviously for A2 power n we have 1, 2 is A1 power 2 power 2n, right? And A1 is 1, so it's 2 power 2n, which is 2 power n squared. So we can guess like an maybe n squared. So we will try to prove this using induction. So suppose the base case is obviously true. A1 is 1, which is 1 squared, right? So base case. Now proof by induction. Suppose this is the hypothesis. For all k equals to 1 through n, we have a k equals k squared. Now we have now putting m equals to k minus 1 and n equals to 1 in this equation. In star, we have not this equation, the original equation, this one. So am plus n plus am minus n. So ak plus k minus 2 equals to half times a2m minus 2 plus a2. From our assumption, we have a2m minus 2, just a minute, not 2m, it's 2k minus 2. So we have 4k minus 1 squared plus 1, which is 2k squared plus 1 minus 2k plus 1. This is equals to ak. I guess we should put n here, since we assume this to be true for all 1 through n. So an minus 2, a2n minus 2, n squared, 2n plus 4n. Okay, so sorry. So we are left with n equals to n squared. Just a minute. Oh, I had assumed till n, right? Let us assume till n minus 1 since we proved for n. That's we have to put m equals to n and n equals to 1. This n and this n are confusing, but these two variables are different. It's by induction or what was that? N equals to n squared for all n in naturals. So we found an expression for n. Next, number 7. So Fn and Gn are polynomials of degree 2014. So degree of Fn equals to degree of Gn equals to 0.14. We also have Fn equals or Fn plus minus 1 power n times Gn equals 2 power n for all n inside 1 up till 4030. We'll find the coefficient of x power 2014 in gx. So coefficient of what's the coefficient? So how to get this one? Anyone? Ideas?
What's the answer? Like, is it 3 to the power 2014 by 2 to the power 2014 by 2014 factorial?
Yeah, how will you get it?
We can use binomial. Like we can define uh, for a x even. Uh, First, we can take for a x odd,
Oh,
and
there is
then
no x. Okay, you
I, I
mean this? Okay,
we
okay.
can define fx, right? Because f
So
and g
for
are both
x,
polynomials.
okay, so for x even we have fx plus minus 1 power x gx is
And
equals to 2 power x. So here minus 1 power x is 1. So since x is even, we can write it as some 2k. So g2k f2k equals to 2k is 4 power k. Write it as 4 plus 1 plus 3 power k. So it's sum over items from 0 through k. 3 power k kci, right? Similarly for x odd, we have x equals to some 2k plus 1 for some k. Sorry. So 2k plus 1 minus, since minus 1 for odd is minus 1, g 2k plus 1 equals to 2 power 2k plus 1. So that is twice of 4 power k. That is 1 moves from 0 okay, KCI 3 power k, 3 power I. Now what to do?
We can assume the coefficient, like let it be something x, not x, I mean something, and then we can just as g is polynomial, so here the coefficient, like we can subtract those two equation and then we can get that the coefficient of this, and like basically the 2 into 2040, like basically 2 to the power 2015 into that coefficient is equal to coefficient of this thing, and the LH, right, like the RHS of the both the side is already a polynomial in k. So basically we can see that as it is given that the value satisfies from 1 to 4030. So for even case the maximum value will be I mean I mean for odd case the maximum will be 2014, and for even the maximum will be again 2014, because we've taken that 4 common. So so basically that's the polynomial, and then we can compare the coefficient. Uh, this is how we can do, right?
Yeah, so okay, so let's subtract it. Let's see what happens. 2k. So the let's assume the leading coefficient of this thing be a and leading coefficient of g be b. So 2 power k power a times 2 power k power 2014, b times 2k power 2014 minus a, 2k plus 1 power 2014 minus, this is plus, okay, 2k plus 1 power 2014. We'll see the right hand side later. Let's see what happens in the left hand side. So this obviously nullifies the leading coefficient with a, right? So leading coefficient now only has contributions from b. So b 2 power 2014. From there we have another 2. Yeah, that's it. So that's the leading coefficient. We have obviously we have k power 2014 into 2. No, not 2, just k power 2014. On the right we have so so basically we have 2 times 3 power I. So we're subtracting more than we are adding, right? Something is off here. By the way, this had a range, right? Yeah, 4040 4030. So 4030 by 2 we have 2015. Okay, so we can go till 2015 with this range with this k. So that's where we can pick one 4 out before expanding. So it's 4 times 1 plus 3 power k. So we have eigenvectors from 0 through 4 times
K minus
k
1.
minus 1.
Like here 1 plus 3 to the power k, not k minus 1. After taking 4
Yeah,
common.
yeah, sorry. So then we have k minus 1 ci, then 3 power I. We can put 2014 in place of k to get the maximum value. You can put anything. No, okay, not 2014, even 2015. That's the maximum value of k. 2015. Like even
Not
if we
is
continue,
right after taking 1 4 common.
yeah, 2015. Oh. Similarly, here it's this square so big. No, square not so big. So this is also 2014 since 2 what is that 4030 minus 1 by 2 is 2014. So now if we subtract for all the 4 times sum over k minus 1 ci 3 power I k ci 3 power I. So if we take 3 power I common, we have 2 also common, then 2 times 0 through 2000. This thing is uh,
Basically, this is polynomial in k, right? So the coefficient must be the same.
yeah,
Uh,
we should
that
only equate the highest coefficient. So
highest one will be 14 power.
this one has, so this from here we getting 4 times 3 power 2014, and this k can go up till yeah, this also can go only up till this k is 2014 15, right? So 2014 c 2014, this is one, nothing else. Just this is this is
how we can put k is equal to 2015 there? Like it is the polynomial, so is the variable here as x, like in polynomial, right? So we can just expand this like k minus 1 choose I, as we do, like it can be written as I minus k plus 1 and multiplied by I minus k plus 2 and like this. So this is overall polynomial divided by 2014 factorial. So the coefficient of k to the power 2014 will be 3 to the power 2014 by 2014 factorial, and then we can
No,
subtract,
why are we dividing it by 2014? Like,
because we can just expand it normally, like we expand a
okay,
simple
okay, okay.
and choose m.
So this is 3 power I times I factorial times k minus 1 minus I factorial and k minus 1 factorial up in the top minus 2 sum over 3 power I times I factorial k minus space k minus I factorial and k factorial. Now if we try to simplify these summations over the same range, taking 2 common 3 power I times this one has a k minus 1 k minus I more than that, or we can so we can not 4, so 2, then summation we can take common 3 power I k minus 1 factorial I factorial and k minus 1 minus I factorial. So that gives us 2 minus k by k minus I. Nothing more, nothing less. So that is 3 power I times k minus 1 ci minus k by k minus I. That was exactly what I was doing a bit while ago.
No, I was saying that we can just reduce this factorial, like k minus 1, we can divide k minus 1 factorial divided by k minus 1 minus I factorial, and then we can write it like it will be k minus I times k minus I plus 1 k minus I plus 2 till k minus 1, right? uh yeah, no, k minus I only, not plus 1.
Then it starts from k minus 1.
Yeah, sorry, yeah. K minus 1 then, and this is basically to get the basically the power of k, like 2014 power, as the maximum power will be 2014 in this polynomial, right? For I is equal to 2014. So we can just, and similarly for odd case also. So we have two polynomials, and then we can compare the coefficients, right? I was saying
Uh,
this
just a minute. I
two
Okay,
polynomials
this
in K.
problem I will try to solve it in some different way and let you know next week. Okay,
Okay,
leave it
but
for
this
this
is
one.
this correct? Like my solution.
I will recheck. Okay, I just think there we are messing up with the limits and all that. We'll just check. Okay,
Okay.
let's leave it for today. Uh, no, we are left with just one problem. I guess it's easy one, so let's just So I haven't covered up integration yet still. So this is the inequality we need to show. F dashed x squared dx. F is continuous differentiable, or it's a C1 function. So f is C1 over AB. And fa is 0. That's important. We have to show this. Pretty easy. We can use this Cauchy-Schwarz inequality. That's the integral form of the Cauchy-Schwarz. So fx gx dx is less than or equals to fx dx times integral gx dx. I mean fx squared x fx squared dx and dx for dx. So we first know from the fundamental theorem of integrals that fx minus fa is integral a to x f dash x or f dash t dt, right? And since fa is 0 from the given conditions, we have this one. That along with this inequality, we can take fx equals to fx and gx. Sorry, you can take fx equals to f dash t, gx equals to 1 here. So that gives us fx equals to a through x f dash t dt less than or equal to 1 times a to x dt, I mean 1 squared dt, and a to x f dash t squared dt. So it's x minus a. This is f dash t squared. So we got this inequality. Now we can just integrate from a to b. So that gives us should we integrate just
Whole
yet?
square, like in LHS by CS.
CS there was a squared or what?
Fx gx whole square, right? I mean, in CS we have integral of fx gx whole square.
Okay, I wrote the CS wrong.
Yeah.
So this one. So we have a whole square dx here. So that is fx whole squared dx. So integrating it from a to b. Integrating it from a to b, we get what do we get on the left hand side? What do we need to prove? Okay, we already have the left hand side. I don't need to simplify the left hand side further. This is the left hand side. Right hand side, we have, so b this x, just a minute. This is the variable over here. Okay, dx. Dx. Yeah, dx. But with dx, we may get some problems.
We can simply give the upper bound, like x minus a is always greater than b minus a because x belongs to a to b.
Okay. So before integrating,
Yeah.
before integrating x minus a2 not bx, f dashed t squared dt, this is less than b minus a2 x f dashed t squared dt. Now if we
Here
integrate
also it
to
can
this,
be a to b, right? Because f dash whole square is greater, like always greater than 0.
okay, yeah.
And then
So
we are
positive.
done because this is constant. So we have to
This is
just
a constant, so it will just go out. So dx, this is b minus a times a to b f dashed t dashed t squared, there is a square. And this integral is again a to b dx, which is a b minus a. So it's b minus a squared times a to b f dashed t squared dt. And the LHS is already nice. Okay then, so we'll discuss the seventh one next week. And if you have any doubts with the MCQ questions, you can
okay.
just
Can you just take the fifth question once
yeah, sorry.
more? Your solution to the fifth question.
You mean subjective?
Yeah, this only. Like last line.
Yeah.
Here I think like 3x square y has the minimum, like it has the maximum value 3y cube in negative, right? So can we write this like a
Yeah.
negative of 3y cube minus 3y cube is always less than minus 3x cube y, x square y.
Yeah.
Not like always greater than, sorry, always greater than because of negative sign. Minus 3y cube is always greater than minus 3x x square y.
Like so, y cube is greater than x cube. So minus 3y cube is greater than minus 3x squared y. Right.
Yeah,
No, sorry,
yeah.
not greater, less than. We are inverting the
How?
inequality by multiplying with minus 1.
Okay, y is greater than x. Oh, I thought x. Then how can we give that bound? Like how x cube is greater than like how x cube? But then y cube must be greater than x cube, right? Then how we can give this bound? X cube
Yeah,
must
we
be.
are. You mean here we are replacing it with y, right?
Then
Hmm.
how can we? Because y is greater than x, so it is not less than this thing. If y is greater than x, do you get what I mean?
Yeah, yeah, I get it. So,
I
if
have a
we,
solution. I think a
yeah,
different
please.
approach. I mean, we can break this to like 2xy square in xy square plus xy square, right? X cube plus y cube, just right. Uh, X cube. No. This thing not. I'm not saying this. I'm saying we
We
can
can
write.
break it into xy squared, right? What's the issue?
No.
Then,
I'm saying I'm saying this. We can just like we can write 2xy square is equal to xy square plus xy square, right? We can just
just a
simply.
minute, I can't hear you.
Okay. Can you
Yeah,
hear me now?
yeah. Now,
We can just simply write this x cube plus y cube minus 3x square y plus xy square plus xy square, right? Yeah, yeah. And then we can just take from from here. Yeah, yeah. From here we can take x common. We get we can more simplify this. We get x times x square plus y square, x times x square plus y square plus y square x plus y. x plus y. Now by AMGM we have that x square plus y square is 2 is greater than equal to 2xy, right?
Yeah.
So this is so the first one will be just 2x square y
So you paired up
less
this
than equal
two
to.
and you paired up
Yeah,
this two,
yeah.
and this is left behind.
No, the only yeah 3x square. This thing is left. Yeah, we can write
Okay.
that
So this thing is
2x
2
square
squared y.
less
This
than
is,
equal.
yeah. So we are lessing everything.
Yeah, and then we can also do this
Less than or
similarly
equals
because
to
y is greater
minus
than
x
x.
squared y, and plus y squared x plus y is less than or equals to minus x squared y, and this thing is 2 root xy. It-
I mean, not two root. We know that y is greater than x, right? So this bound is simpler. Like it's trivial that it is always greater than x square, right?
Okay, so we can just kick this y out. No, no, we needed 2. Okay. Okay, we replace it with x instead. Yeah, so then we get,
It, yeah.
oh, we don't need that, but still
I
we
mean,
need 2x y squared. Oh yeah, sorry. Uh, we need to
I
make it
mean,
what? Y x squared y. Okay, okay. So we have to replace this with x and this with. We have
no,
to ditch this one. Ditch x.
no.
So,
We have to replace this everything by x square y, right? I mean, we already have 2x square y. If we write that this is greater than equal to x square y, then we can just add up and get this is overall greater than 0,
yeah, yeah,
and which is
yeah,
easy because y is greater than x.
yeah, yeah. That is easy. Okay. So y is greater than x. We're replacing a smaller number x with y. We are not going to the same direction. We are making it lesser and less, and still getting it to be positive. Okay.
Yeah.
Okay. Thank you. So that's how we somehow complete the proof. And I will post the MCQ answer key in the G class sometime tomorrow. We can discuss the seventh one next week.
So will you post these two?
Which two?
Means I'm asking whether you will post these notes too.
Yeah, yeah. I will post these notes too, and you will get the recordings also. I guess as I do it every week.
Can you please tell the final answer for the seventh one? I can match my answer. Like, what is the
I
final?
haven't computed it yet, so I will do it next week and let you
Oh,
know.
okay.
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 Okay, then. Good night. Thank you. Bye.
Good night.